Um, is this Zaina or Zena? Can you please introduce yourself, dear?
Yes, sir. I'm
Yeah.
Zaina.
Okay, Zaina. Okay, dear. So, which class you are, bache?
So I have math now with Namrata ma'am.
Okay, you have maths right now. Okay. So, dear, basically it's physics class. So, I think there might be some basically breakout rooms for you. Just
Hmm.
a moment. Okay, just a second. Let me check. Harshit, are you there, dear?
Sorry, sir.
Are you there?
Yes, sir.
Yeah. So Harshit, I just wanted to say one thing is that, dear, please. So, are you available at 8:30, like IST?
No, no, sir. Actually, I have to go somewhere, so that is why.
Okay. Tomorrow.
Yes, sir. Tomorrow I will be available.
So when you will get free today, when you will from outside.
Sir, actually, it will be like 11:30
Okay,
p.m.
okay.
So,
So that would be a little bit like so much late. So what you can do is that, dear. So today, like basically, this is the topic that is already started in the previous class, and like almost three class have been done so far in this batch. So what I will do is that, dear, in the tomorrow, like tomorrow and day after tomorrow, I will take two classes of yours. Okay. So that I can
okay,
complete the start from the start, so that you don't get confused in the topic. Okay. So because if you wanna stay in this class, you can. But if like it would be better if you join. I will give you the backup classes for you. Okay.
sir, tomorrow.
Yes, tomorrow and day after tomorrow, I will give you backup. I will share the timing by tomorrow itself. Okay, don't worry about it. Okay.
Okay, sir.
Like for tomorrow, I'm sure 8:30 will be the timing. IST.
Okay, sir.
Okay. So please join. You will get the link. Okay.
Hmm.
Or if there is any time change in timing, so the management will let you know about it. Okay.
Okay, sir.
Okay, dear. Thanks so much, dear.
Yeah.
Okay, that's great. Bye bye. Take care. Zainab, please, can you please contact to management list, ask them whether the class will be on the same link or on the different link.
Yes, sir. I'm doing that.
Yeah, because okay, that's great. Okay, Nabila and Gianna, how are you, Bacho?
Fine, sir. Alhamdulillah. How are you?
I'm fine, dear. Thank you so much for asking. Actually, like the fast was looking very tough for me. Yeah, basically today, I was just unconscious, just like from the Zohar itself. So that's why. Now I'm a little bit stable right now. Okay. So let's start the class without any delay. Okay. Gianna and Nabila. Gianna, are you there, dear?
Yes, sir.
Okay. That's great. How are you, dear?
I'm fine, sir.
Okay, that's great. Okay, so have you revised the topics, बच्चों?
Yes, sir.
चलो ठीक है. That is good. Nabila, will you be free by tomorrow? So basically, I just wanted to start the first topic with Harshit. So I was thinking that if you join that class, so that would be good for you, if it's possible.
Yes, sir. But the timing, I'm free tomorrow. It's just by 5. It will be good.
5. So you live in Saudi, right?
Yeah, Middle East.
Middle East. Like the time difference between India and that place is 2.5 hour, 1.5 hour.
Um, I think 2.5 hours.
2 hours. So basically what's your space like place?
I'm in UAE,
So
so
you are in UAE. So that is 1.5 hour difference here. If you are in UAE. So
yeah. But
okay. So to according if I'm saying that 8:30 will be the time, so like at your place that would be 7 o'clock. So is it fine?
um, I'm not sure, sir.
Okay, you are
But
not
I'll
sure.
see you tomorrow.
Okay, चलो ठीक है. Let me check कि कुछ और let me look into that like if I basically change the timing or if I make that to 9:30, so that would be for you as 8 o'clock, so that would be fine. If it's possible, they will let you know.
1 minute, sir. So I'll
Mm-hmm.
see. I'll let you know later.
Yeah, you are saying
Because
something, Nabila?
yeah, I will see later. Or maybe
Okay,
I'll
okay.
just check the recorded class.
Okay, चलो ठीक है, no worries. Okay, no worries. Okay. If it's possible, so you can join. If it's not, so we will look some other options when others new students will join. I will take your class with them. Okay, don't worry.
Sure, sir. Thank you,
Yeah,
sir.
welcome. Okay, so let's start the class without any delay. Actually, we have wasted a lot of time. Sorry for that. Okay. Okay, so the last class where we were doing. So basically we were doing the image formation of a spherical mirror. Basically, it's a concave mirror, and we have done the three parts. That is, the first one is of infinity. Like the rays were coming from the infinity, okay, and basically they were converging at the focus. Clear?
Yes, sir.
Next is basically your case was around like beyond C. Now the object has moved towards the pole, so it means that the next position of the object would be beyond, you can say, curvature. So now the object will first ray. I've told you the first ray. Whenever you are going to draw the diagram or the ray diagram, just do one thing. First ray should be parallel to the principal axis, and it will pass out through the focus. So that should be your you can say fundamental line to draw the ray diagram. Clear?
Yes, sir.
चलो ठीक है. Next is basically now you have multiple option. Either you cross this line from center of curvature, so it will basically retrace its path. Okay, when the line passes through the center of curvature, so it is radius. So there is a property is that when the basically your radius is perpendicular to the parameter or the point at which it basically falls. Okay, this is the property of a circle. So if the angle is 90, so angle of incidence would be 0 degree. Yes or no, Nabila and Gianna?
Yes, sir.
Okay, so that's why it will retrace its path due to angle of reflection will be zero itself. So you have multiple options. Either you pass it through the pole so that again angle of reflection, basically law of reflection is getting followed here, and this is the property of the circle. Clear? If you basically pass from the, you can say, center of curvature. Or another option you have is that if you pass the line from the focus, so it will get parallel to the principal axis. Clear? So you have three options. You can opt any of them. Your diagram will be as it is. Clear? Nabila and
Yes,
Gianna,
sir.
is it clear, bacho?
Yes, sir.
Chalo, that's great.
Yes.
Very good, very good. Any doubt so far?
No, sir.
Okay. Next is at C. So at C, the image will be formed at C itself and will be of the same size. Clear?
Yes, sir.
So that's great. Next one will be fourth is basically now the object will move forward towards the pole. So it will be between center of curvature and F. Clear? I'm telling you, both of you, Vicho, it is a very important topic. Every single time in the boards there will be a question, like either they will give you to complete the ray diagram, or either they will give you a certain case of among all, like from these cases, and they will ask you to draw the ray diagram, and they will ask you to draw basically to identify the nature of image, to draw basically identify the size of image, and where the image will be formed, where the object is placed. So there will be certain you can say pairs of questions from this topic itself. Clear?
Yes, sir.
So that's why keep practicing for this topic if you want, like if you don't want to lose the marks. Clear? So between C and F. So just a second, let me copy paste it. Now the object is between C and F. The first ray should be parallel to the principal axis, and it will pass through the focus. Yes or no? Nabila and Gianna.
Yes, sir.
Okay. Next ray, you have the same option. Either you go with the focus, like if you pass the line from the focus, it will basically what happen? It will get parallel to the principal axis. Yes or no? Or either you have the option, if you strike the light on the pole, the light will reflect back with the same angle. Yes, Nabila and Gianna, tell me, is it clear?
Yes, sir.
Okay. So right now, Jacob, so I am doing this thing from a rough hand. I don't have any scale. So there will be asymmetry if I basically, if basically, you can say consider certain situations. So there will be asymmetry. So that's why when you will draw from the scale or the ruler, so all the cases, all the points will be at the same point, like they will intersect at the same point. Okay. So right now I'm
Okay.
considering this one that the light is getting striked at the pole, and it will reflect back with the same angle. Okay. Okay, Nabil and Gianna, is it clear, Bacho?
Yes,
So now you can
yes,
see
sir.
this thing that intersection point is here. So okay. So basically now can you tell me the image position of image, Bacho?
Beyond C.
Beyond C. Okay, very good. So is it enlarged or like of the same size, or what kind of image it is?
Enlarged.
Enlarged. Okay. Gianna, are you there, Bache? What happened? Why are you not responding, Bacho? Gianna?
I'm there, sir.
Okay, okay, ठीक है. Okay, okay, no worries. So next is, so basically now U is equals to between C and F, and V is equals to is basically beyond C, and nature of image will be
Real and inverted.
real and inverted. Very good. Okay, and size?
Enlarged.
Enlarged.
Enlarged. Or you can say magnified. Both word can be used. So you can see this is the enlarged image. The height is a little bit. Okay. Okay. So next case is now the object will move forward toward the pole. So what will be the next position, Micho? Tell me.
At F.
Okay, Nabila said at F. What about you, Gianna?
Also, between F and C.
Between F and C, it's already there, dear.
Oh, sorry, at F, yeah.
At F, yes, it will be at F. Very good, both of you. So it will be at F. This is fifth part. At F. So now object is placed at F. So first ray should be parallel to the principal axis, and it will pass through the
Focus.
focus. Very good. Okay. And second ray will pass through the center of curvature. Just a second. या फिर मैं यहाँ से पास आउट करवा देते हैं. Okay. Now you can see this thing. If the object is placed at F, then the image formed will be at infinity. So this is these rays are going to meet at infinity. Clear? So now the object is placed at F. This is the this is the you can say opposite case of the first case. Clear? V will be at infinity. Nature, what will be the nature, Bacho? Nabila and Gianna, tell me.
Real and inverted.
Real and inverted. Size?
Enlarged.
Okay, Gianna said enlarged. What about you, Nabila?
Enlarged.
So it will be highly enlarged, okay? Or highly magnified.
Okay, sir.
Or I'm writing just magnified here, okay? So that you will just understand that highly will be associated. Okay? Highly magnified. Okay?
Yes, sir.
So next case will be, what will be the next case? Can you tell me?
Between F and P.
Between F and P. And this is you can say one of the most important case, or you can say not important, a little bit confusing case. And this is the only case in which the ray, basically the concave mirror forms a virtual image. Clear? So this is the
Yes, sir.
sixth case. Okay, Gianna and Nabila, is this clear to you, dear?
Yes, sir.
Yes, sir.
Between F and P. Okay? So let me raise this thing. Object will be placed at here. So what should be what will be the at which position will the first ray pass?
parallel to principal axis.
Parallel to principal axis, and it will pass through the focus. Okay, like
Yes, sir.
this. Okay. Okay, and next will be the basically law of reflection. Okay. So you can see this thing that these rays are not going to meet at any point if I extend this line in the actual direction. Yes or no?
Yes, sir.
Okay. But what happens is that now the virtual image point comes into the picture, and it says that if I extend this line in the backward direction, okay, if I extend this line in the backward direction, so these rays are appears to meet. These rays appear to meet. Yes or no? Okay.
Oh,
And one more thing, the line that these extended line should be drawn with the dashed line. Clear? So I don't have any option to draw the dashed line. So that's why I'm using a little bit like that's why I'm using this line itself. Okay, like this. Okay.
Yes.
So now you can see this thing that if this is the object, basically this is the intersection point, not in the actual intersection point of these is clear like this. Okay, so this will be the image. Clear? So you can see this thing that is a virtual image. Yes or no, Nabila and
yes, sir.
Gianna? Okay, so now this is just a second. So it will be, so u will be equals to between f and p. Okay, and v will be equals to, now the object, now the image is formed behind the mirror, so it will be behind the mirror. There isn't any specific position, so it will be just only behind the mirror. Clear?
Yes, sir.
And nature will be
Virtual and erect.
virtual and erect. Very good. Okay, and size will be
Highly
Um,
that would be enlarged only. Okay, enlarged or magnified. Okay, highly enlarged will be in only in the case when the rays are basically basically meeting at infinity. Clear? Enlarged. Okay, so now Nabila and Gianna, please tell me, is this clear to you, dear? All both of you.
yes, sir.
Yes,
Any
sir.
doubt so far, bacho?
No, sir.
No, sir.
Sure.
Yes, sir.
Sure, sir.
Chalo, theek hai, that's good. So now, okay, so let's write. So these are the 6 cases of the concave mirror. Clear?
Yes,
Okay.
sir.
Okay. Just a second. Okay. Okay. So I'm basically pasting a table here. Okay. So like I've written all the things itself, but what I'm doing is that I'm pasting a table. So, and basically summary of the image formation by the concave mirror. Clear, both of you?
Yes, sir.
So basically, just a second. Okay. So this is the actually in this table. So first, like that sequence that I followed, like basically in this table, the reverse is followed. Okay. So you just have to a little bit weird when you will when you're going to take the reference from it. Okay. So the question is basically the only they have taken the virtual erect in the first case, and then the focus, and then between F and C, then C, between beyond C, and at the last one is at infinity. Clear?
Yes, sir.
So they have taken, so just the follow is like the basically the pattern or the sequence is reversed, but all the things are clear. Clear?
Yes, sir.
Any doubt so far, dear? Both of you?
No, sir.
Okay, okay. So these are the 6 cases that you have to understand, okay? And let's do some applications of concave mirror, okay, before ending this topic, okay? First, let's do the concave mirror applications. Arre, concave mirror. So let's understand. The first is basically, so concave mirror are used for the shaving mirrors. Okay, so men used some shaving mirrors when they basically shave their faces. So basically, they the you can say the situation or the object or the position of the mirror is between this. The first case is followed because in that case, image is formed virtual and erect, and the image is also enlarged because they have like that basically is there, you can say, to do the shave. Clear?
Yes, sir.
Okay. Okay. Next is, concave mirror are used by the dentist to see the large images of the patients, and this is the case in which the large image is formed and the image is also virtual. Clear? Okay.
Yes, sir.
Like the mirror is basically placed in at a specific point in which basically the object is between focus and pole. Clear? So next is
Yes, sir.
basically concave mirrors are used by the dentist. Clear? Next is, concave mirror are used as reflector in torches. I will give you basically, I will draw that, I will paste the picture here. So basically, the concave mirror is placed inside the torch, and the you can see the bulb is placed inside the torch. Yes or no?
Yes,
So
sir.
there is a bulb placed inside a torch. So basically that bulb is placed at the focus point. So when the light strikes on the concave mirror, so what will be the kind of ray direction? Can you tell me if the point basically source is placed at the focus?
Parallel.
Parallel, yes. So you have seen this thing that when you basically open the torch, so the basically light beam is of parallel. Yes or no?
Yes, sir.
Okay. So that's why. Clear?
Yes, sir.
Any doubt?
No, sir.
Yes, sir.
That's great. Okay, next is, so I'm writing here. Concave mirrors. Reflectors in torches and vehicle itself. Okay. So you have seen vehicle headlights. So the concave mirror is also placed in that. Okay.
Yes, sir.
Yes, sir.
Okay, Nabila and Gianna, is this clear to you, dear?
Yes, sir.
Any doubts so
Yes, sir.
far?
No, sir.
Okay, and a large the another example is like four examples, so like four applications are enough. So and the next example or like application, that is, so large concave mirror are used to heat solar furnaces. So basically, the concave mirror are used to focus the sunlight, okay, at a specific point to basically to heat up the solar furnaces. Furnaces means that the kind of, you can say, which in which a kind of like metal is melted. Okay,
Yes, sir.
any doubt?
No,
No,
sir.
sir.
That's great. So large concave mirrors are used in is my writing readable to both of you?
Yes, sir.
Okay.
Yes, sir.
Okay. Solar energy to focus sun rays for heating solar furnaces. Because concave mirror is a converging mirror, yes or no? It means that they converge the light they, okay?
Okay, sir.
Yes.
Sun rays for heating solar furnaces. Am I clear to both of you? Please tell me.
Yes, sir.
Any
Clear.
doubts so far, bacho?
No,
No,
sir.
sir.
Sure.
Sure, sir.
Chalo, that's great. So this is the topic of image formation by concave mirror. Okay. So we have done the ray diagrams. We have done the ray diagrams of this concave mirror. Okay. And we have done the properties as well. And we have done the, I mean, like this is the summary of this table, clear? And these
Yes,
are
sir.
the applications of mirror. Please tell me if it's clear to you finally.
Yes, sir. It's all clear.
Okay, it's all clear. Gianna, you tell me. Nabila
Yes,
is
sir.
saying clear to her. Okay, ठीक है. So next thing basically is convex mirror. Clear? First is concave. So next one is going to have the convex mirror. Clear?
Yes,
Just a
sir.
second. Let me paste the picture of that. Just give me a second, bachcho. Just pasting the picture, just a second. Okay, so this is the convex mirror in front of you. So as you can see, convex mirror, the polished or the shiny surface is outside, okay? Convex mirror is opposite to the concave mirror, clear?
Yes, sir.
Yes, sir.
Okay, so next is that is, let me write it here inside. That was this is concave mirror now. So it is, you can say first, okay? And this is second. And basically all the things that we have done so far, like all like if I say the relationship between radius and curvature and focus, it's also applicable for convex mirror, okay? And the difference between that is basically in the convex mirror, basically the if I draw a line here, suppose that this is the principal axis, okay? And if basically you can say if the rays are coming from the infinity, so what will happen, Bicho? Tell me, Nabila and Gianna. If the rays are coming from parallel, so this is a diverging mirror, so it will diverge the rays, clear? Diverge means it will spread out the rays, clear?
Yes.
Yes.
That's great. Okay, next is basically this is the thing, so it will like this, okay? So what happens is that basically if you extend these lines in the backward direction, you will find that they appears to meet at a certain position. That is the, so the focus is basically behind the mirror, clear? Of the concave convex mirror, clear? Both of you, Gianna and Nabila.
Yes, sir.
Yes.
So now for the convex mirror, the focus is at this point. This is the focus. Okay. So first of all, we have 5 minutes, only 5 minutes. So let's do the some characteristics of concave mirror. Okay. So in the next class, we will do the image formation as well as the applications of mirror. Clear?
Yes, sir.
Okay. So the first, so basically the you can say the characteristics or the properties for the convex mirror is that the focal length of the convex mirror is positive. Okay.
Yes, sir.
Just a second. Actually, my pen is lagging a little bit.
So the center of curvature would be towards the right side.
Yes, that would be towards the right side. Yes, yes.
Okay.
The first characteristic you can say is that convex mirror always form virtual and erect images. Clear, Nabila and Gianna? Okay. Next is basically convex mirror always form diminished images. So no image is in enlarged shape produced by the convex mirror. Clear?
Yes, sir.
Next is basically convex mirror has a positive focal length. Clear, Nabila and Gianna?
Yes, sir.
Okay, that's good.
Yes, sir.
Next is convex mirror wide view. Okay. So basically, so as you can see this thing that the rays are getting spreading out, spreading out. So it means that you will get a larger view of basically larger view or wide view from a convex mirror. So that's why in the rear view mirrors of the car, we use convex mirror because they provide you a larger area to see. Okay. In comparison to concave mirror. Clear both of you, Nabila and Gianna?
Yes, sir, it's clear.
Okay, wide view of vision. So these are some basic characteristics of a concave or convex mirror. Clear, Nabila and Gianna?
Yes, sir, it's clear.
Any doubt, Bicho?
No, sir.